Okay, if velocity versus clock time is a straight line through the origin, and if this represents the velocity of a ball starting from rest, traveling to the end of a ramp, then this point represents the time and velocity coordinates at the end of the ramp. Then the time interval is this, the final velocity is this. I represent the final velocity by VF. Now the question is, how far does the ball travel in achieving its average velocity? Well, straight line graph, starting at the origin, the average velocity is going to occur at the midpoint of this segment, or at the midpoint of the time interval, or at the midpoint of the velocity interval. So we see clearly that at this point we have half of the final velocity. So that, and the time coordinate is half of the time interval that we have for the entire ramp. So what we have here is a triangle whose area represents the distance you travel in achieving the average velocity. This triangle has half the base and half the altitude of the original, giving it 1/4 the area. We conclude that the ball achieves its average velocity after traveling 1/4 the length of the ramp.